Okay. So you've got to have different denominators on everything that you're doing with these. Big thing to remember is that if you change the numerators or if you change the denominators, you have to change the numerator. Okay. And then, so once you get it where everything's changed, you've got the same thing in the denominators, you go back and add or subtract your numerators. And remember that whenever you're adding or subtracting, that you keep the denominators the same. Okay. So if you have different denominators, change the numerators or change the denominators so that they're the same. Whatever you do to change the denominator of one part, you have to do the same thing in the numerator. And once you do that, then you go ahead and add or subtract whatever you have in the numerators. Don't change the denominators. And at the very end of it, you always have to go back and then simplify at the end by doing some factoring first. So you have to factor and simplify if possible at the very end. Sometimes you do, sometimes you don't. It just depends on the problems and how you go through the numbers with these. Okay, so in 7.4, where we left off last time, we had done the first 5 objectives. So this would be objective number 6 we're looking at. And it's just going to say should just say to add or subtract the rational expressions. Actually, this says adding. And pretty much all the objectives here in the middle, even the ones we did before last time, and pretty much everything here, they're all going to say that you're adding in rational expressions. So those parts aren't going to change any. The only thing they're going to do is just change how the fractions look as you go through the parts here. Okay, so they'll start off, with a fairly tame fraction when you're going through these. So you got 6 over 5y plus 1/5. Okay, and very first thing is you have to figure out what your least common denominator is going to be. Obviously, it's got a 5 in it, so that part's got to be there. But this one has a y and this one doesn't. And again, if you're getting the least common denominators, you always take the biggest power. So for that one, it would be y to the first power, because this one has a y and that one doesn't. Okay, so the first fraction didn't change. It stayed exactly the same. The second one, though, when you put 5y in the denominator, to go from here to here, we multiply by y. And whatever you do in the denominator, you have to do the same thing in the numerator. So you change that one to 1y. Okay. If you want to put a 1 there, then you can do that. And once you've got the common denominators, go ahead and rewrite it as one fraction, and go ahead and do 6 plus 1y, or you can just do 6 plus y there. And then from that point, if there's anything you can do to cancel or simplify or factor or whatever you can do that. And just remember that anytime you put the plus sign there, that those are, you can think about that being in parentheses, even though you won't really use it there. That if you're going to cancel anything, you have to have the same thing with a 6 plus y in the denominator to cancel that. Yeah, so there's nothing you can factor, nothing you can cancel. So that one would just stay as 6 plus y over 5y. Okay, same kind of problem, just a little bit different. look at it here. 1 over 3 plus 2 over c. Okay, so for this one, your least common denominator, you got a 3 and a c, so it's got to be a 3c. Okay, so in the first fraction, we went from 3 to 3c in the denominator, so we multiplied by c. You got to do the same thing in the top. We'll multiply this one times c also. So that's 1c. And on this problem, we went from c to 3c, so we multiplied by 3. Same thing here, we got to multiply by 3. Okay, so 2 times 3 makes that out to be 6. Okay, so if we put it all together, it's over 3c. You've got 1c plus 6, or we just call it c plus 6. And again, there's nothing in the denominator to cancel because, again, sometimes people kind of want to attempt to go back and cancel out the c's. But again, anytime you've got a plus or a minus, you have to connect those pieces together. So really it's c plus 6 that's packaged together over 3c. So for that one, that's as far as that one would go. Okay, objective 7, same thing, still going to add and subtract. They just, still basically the same look on the fractions with it. They don't really change it till probably the next one or two down the road here. So for this one, we'll go with 7 over 4x minus 5 over 6x. And again, still adding rational expressions. Just talks about the denominators having x terms in there. Okay, so they both have an x, so we know we've got to have an LCD has got to equal x with it. From there, you've got 4 and 6. So you've got to count up by 4s and 6s till you find the first number that they have in common. Shouldn't take too long until you figure out that it's got 12 in it, so your least common denominator would be 12x. Okay, so from this, to get from 4 to 12, we multiply by 3. And again, whatever we do on the bottom, we'll do the same thing on the top. So we'll do 3 times 7 to make that 21. Okay, so from this one, 6x to 12x, we multiply by 2. Do the same thing on top. 5 times 2 is 10. Okay, so bring it all together as one fraction. You've got 21 minus 10. Now, in this, we may stretch it out a little bit because we don't have to. But go ahead and bring it together as one fraction. And that does make that 11 over 12x. Won't simplify. If it had been 10, sure, we could come back and divide them both by 2. But with 11 over 12, that's as far as that one will go, so it just stays 11 over 12x. Okay, so let's go 5 over 8b minus 3 over 4b. Okay, 8 and 4, again, as you get bigger, first number they'd have in common would be 8, so the least common denominator would be 8b. Okay, first fraction didn't change. Denominator stayed 8b in both cases, so in that case, you don't change it, it just stays as 5. Second fraction, though, this one we did multiply by 2. So multiply by 2 on the bottom, got to multiply by 2 on the top. So that would have been a 6. Okay, bring it all together as one fraction, so that's 8b on the bottom. Go ahead and do 5 minus 6 on the top. That's negative 1 over 8b. Okay, so again, first couple of objectives they get here with 6 and 7, they're pretty straightforward. This one you just start having to look for multiples of the numbers, just as you make, still got the variables that's there. Next objective, almost the same thing. The only thing that's a little bit different on objective 8 is that the variables in the denominator, instead of just all being to the first power, they go up to the second or third, or maybe fourth power. Okay, so go negative 7 over 6x squared y plus 5 over 2xy squared. Okay, 2's and 6's. You could take 12, but again, the first number they'd have in common would be 6. So that part, number-wise, would be there. And again, with the variables, you always pick the highest power. So you have an x squared, and you have a y squared. So for that one, that would be your least common denominator. Okay, and for problems like that, the first thing I would always do is go back and just rewrite those denominators, and then go back and figure out what you did to change it. So from here to here, 6 stayed the same, so we didn't multiply by a number. We didn't change the x's. The only thing we did different was we multiplied by a y. So if you multiply by y in the denominator, same thing, you've got to do that in the numerator. So make that a negative 7y. Okay, denominator here, we multiplied by 3. We went from x to the first, x to the second, so we put in an extra x. The y's didn't change. So basically on the denominator, we multiply by 3x. Do the same thing on top. So 5 times 3 is 15x. Okay, so the numerator, just bring it all together. We have negative 7. There's not a number with negative 7, 15. Can't pull a number out because there's no common number. One has an x, one has a y, so there's not a common variable. So for that one, that would be just as far as you can go for that. Okay, let's do one more here for that. I can make that look like something y'all can read. Okay, so negative 2 over 7w squared y minus 2 over 3w to the third y squared. Okay, so for your two denominators, 7w squared y, 3w to the third y squared. 3 and 7 don't have a number in common, so basically you just start, you start counting by 3s, count by 7s. Eventually the first number you're going to get is 21. With the w's, again, you got 2 and 3, so we'll take the biggest power. Same thing with the y's. We'll take the biggest power. Okay, first fraction. Going from here to here, we multiplied by 3. We added in a w, and we added in a y. So it's 3wy, and the denominator we multiplied by, so we'll do the same thing in the top. So do negative 5 times 3, and then w times y. Okay, and for this one, went from here to here, we multiplied by 7. And it was okay because it was w to the third and y squared, so we're just multiplying it by 7. So 2 times 7 is 14. Okay, and again, bring it all back together as one big fraction. Negative 15wy minus 14. I mean, if you got really picky, you could factor out the negative, but that's really not going to do anything. So for that one, again, that's about as far as you can take that one. Okay, so everything on those first objectives was 6, 7, and 8. They're all basically just one term in the denominator. You're just going back and finding those. The big change that they go to in objective 9 is that you're still adding subtraction on this one. The biggest thing that's here is that you've got a linear denominator. And again, linear denominator just means it's x plus something or x minus something. X plus some constant that you'll put at the end of it there. Or the other examples, it was always just a monomial that you had on the bottom where it was just the one term. This one now you got 6 over x, which looks like the other part. The second part is we got the 5 over x plus 2. Okay, so for your least common denominator, you've got x and x plus 2. There's no numbers with those. And again, with the x plus 2, as soon as you've got a plus or minus with the x, you have to think about that as being a whole different, unique thing there. So x is one denominator, x plus 2 is a totally different denominator. So for one like that, you're just going to multiply those two things together. Okay, so for the first fraction, we went from x to putting in an extra x plus 2 on the bottom. So for that one, we'll do the same thing on the top. We'll put in an extra x plus 2 on the top. For this one, we had the x plus 2. We put an x on the bottom. So on the top, same thing. We'll have to do 5 times x to make it 5x there. Okay, now here's where we kind of go on that last step we did earlier, that sometimes, with the problems before, we'd rewrite it with a common denominator and it would kind of gloss over. This is one of those where you have to kind of go back and rewrite it with one big denominator, because sometimes if you don't, you'll kind of lose a little bit. Okay, so once you're here, then you're going to go ahead and actually you've got your least common denominator, so you're good there. And this is one of those that when you get to this part where the denominators gets a little bit more complex, I almost tell people, all right, when you do this one, don't even write out what this is. Just put down that this is the LCD, so that we can see that we've got it here. Because sometimes the temptation is that sometimes people want to go back and go, oh, well, there's an x plus 2 and an x plus 2, and I'll just cancel those out. And then when you do that, you're right back to the problem that you had to start with. So the biggest temptation on this one to do is that don't cancel yet. You've got to do everything. You've got to add and subtract everything in the numerator, which means you got to do distributive property first. So you've got 6x plus 12 minus 5x. And I'm kind of one of those that if you didn't do anything in the denominator, I wouldn't worry about rewriting it, because you're just going to, just make the problem a little bit longer. Just keep working in the numerator. Now you've got 6x minus 5x. That's 1x, or just x, plus 12. Okay, now you've done everything you can do, and it's almost like green here. Now that you've done everything you can do in the denominator or in the numerator, now you've got the green light. Now you can look to see if you can cancel here. Well, we got close. We had x plus 12. This one's x plus 2. But again, by that one being a 2 and 12, there's nothing you can cancel. So for that one, that would be as far as you could take that answer. Okay. So when you get to these where you're having the denominator with two terms, where they're calling it linear factors, those are the ones you have to kind of fight the temptation to start canceling too quick, because if you do, you kind of wind up right back, where you started, and then you kind of get stuck a little bit. So, all right, let's do like one more of those, make sure we got it here. Okay, so for this one, we'll go 6 over 5x, then minus 7 over x minus 3. Okay, and again, you've got two different denominators for this one, so when you do your least common denominator, it is just going to be 5x and x minus 3. Okay, so for the first fraction, we had 5x, we multiplied in an extra x minus 3. So we've got to do the same thing on the top. We need an extra x minus 3 on the top. For this one, we multiplied in an extra 5x. So same thing on the top. We've got 7 times 5x. Okay, so again, here's one where we're not going to do anything in the denominator. We're just going to bring it back together. So if you want to just take a shortcut here, just put LCD. We know it's going to be this thing, but it'll speed up the process a little bit too. Because really, once you've got common denominators, all the work is in the numerators. So now you've got the 6 times x minus 3 minus the 7 times 5x. Okay. Again, we're not doing anything in the denominator, because once you get the common denominator, it's pretty much done to the very end. Go ahead and do distributive property here, 6x minus 18. And for the second part here, it's just negative 7 times 35, so that's just a negative 35x. Okay, and on the top now we've got 6x minus 35. So 6 minus 35 is a negative 29x minus 18. And once we've added and subtracted, done everything we can do in the top, now you can bring back in your denominator of 5x and x minus 3, and then look to see if you can cancel. And again, for this one, there's nothing there that we can cancel. So as pretty as that really isn't, that's going to be the final answer that we're looking for there. Okay, and objective 10. Same setup with this one. The only thing that's different about objective 10, it's still the linear objectives, or the linear denominators. The only thing that's different is now is you actually have a few things that's in common with these. So we'll have x over x plus 4, and then 1 over 2x plus 8. Okay, now, and they're actually kind of previewing what's going to happen next because of where we're going for this one. If you look at the denominators and you have something like this where you almost have the same thing, this is one that you want to basically factor your denominators completely. And we haven't had to mention that now because there wasn't anything that we could really factor in the denominators because it was just an expression and there wasn't much there. So if you get to the point where when they start getting a little bit more complex, you want to factor out the denominators as much as you can. And you can factor the numerators too, but for this one, there's really nothing there. The 2x plus 8, you can divide them both by 2. So you got 2 times x plus 4. Okay, and then once you get there, then you can start looking for your least common denominator. Well, they both have the x plus 4, so we're good there. And technically you can think about this one as being 1 times x plus 4. So if you've got a 1 and a 2, well, if you've got an extra number there, you've got to take the number as well. So your least common denominator is going to be 2 times x plus 4. Okay, so for the first one, we multiply by 2. So we'll do the same thing on the top. We'll multiply 2 times x for just the 2x. And for the second one, we didn't change anything at all. So didn't have to worry about it. It just stays the same. So it's 1. Again, bring it all back together. In this case, if you want to put the LCD instead of writing it out, that's okay. And then pull in whatever your numerators work. So it's 2x plus 1. Okay, for this one, nothing you can do with that one. It's 2x plus 1. There's nothing you can do to factor there. So this is one that, now if we bring the least common denominator back in, that's going to be the answer that we're looking for. Yeah, and again, try to fight the temptation to go back and cancel out the 2's here because, again, technically, that 2x plus 1's in parentheses, that it's a package deal because of that plus sign. So if you're going to cancel it, you got to have another 2x plus 1 that's down here. Let's do one more of those. So we'll go 7 3x over 12, and then plus 2 and x plus 4. And again, you do have a little bit you can factor there, so go ahead and factor out the 3 from the 3x plus 12. And again, if you've got something in the numerator you can factor, you can go ahead and do that as well. The problems that they set up here, they're probably not going to do that because they're really keying on the denominators. So go ahead and factor the denominators so we're down to here. And because you've got 3 times x plus 4 and just an x plus 4, your least common denominator would be the 3 times the x plus 4. Okay, first one didn't change, so stay 7. Second one, we multiplied in the 3 on the bottom, so we'll do the same thing on the top, multiply by the 3, make that out to be a 6. Okay, we've got our least common denominator, we're just going to do 7 plus 6, which we can add that together and make it 13. And again, once you've done everything you can do in the top, then go ahead and bring your denominator back in. So that's just 3 times x plus 4. Okay, now that would be one that if that had been 12 instead of 13, that's one where you could go back and cancel those two numbers out because you can divide the 3 and the 12 because there's nothing else behind the 12. But for that case, 13 and 3 won't cancel, so just take that as the answer. Okay, and the last objective that you've got in section 4. Still adding, still subtracting. Biggest thing that you've got for this one with 11 is that now that the denominators are quadratics, they're basically knocking this thing up a power. Okay, now, and it's still going to be, even though this was the linear part back here, it's still going to be that same setup that you still have to factor your denominators. That before you do anything with those quadratic denominators, you do have to do the factoring first. So 1 over 3x squared plus 2x minus 1 plus 2 over 3x squared minus 10x plus 3. Okay, a little bit of good news, bad news. Depending on the problem. Now, this one, the kind of good news for this one is the factor on this one is 1 at the end. So when you factor this one, the only way that you can get 1 has to be 1 times 1. Okay, the only way you can get 3x is it has to be 3x times x. So for this one, there's only one way you can factor this one. It's 3x. The only way you can get 3x squared is 3x times x. The only one way you can get 1 is it's got to be 1 times 1. It's just a matter of getting the plus and the minus in the right place. Because you are going to have to make this a negative 1 at the end. So one's got to be positive, one's got to be negative, and you just got to get those numbers in the right place. If you check it, this is where you just do the O and the I part. That would be a plus 1x. That would be a minus 3x. So if you added those two together, that's a negative 2x, but we need this to be a positive. So that just means we put the signs in the wrong place. So for this one, we need to go back and change that to a negative and change that to a positive. So then we've got the negative 1x, we've got a positive 3x. Put that together and that would be a 2x. Okay, the second one, kind of 50-50 on this one because with 3x squared, we do know it's going to be 3x and x. The problem is it could be that you've got a 3 here or a 1 here, or it could be that you've got a 1 here and a 3 here. So you can either guess and check on those to kind of figure out what it wants to do. But probably what they really want you to do for this one is go back and do just your factoring methods. So for this one, you've got 3 times 3, which is 9. So you need the factors of positive 9, where the sum would equal negative 10. Oh, it's got to be 1 and 9. 3 and 3 is not going to get us there, so it's got to be the 1 and the 9. Because the b term is negative, the bigger number, bigger factor has to be negative. If you do a positive divide by negative, it makes that one a negative. Okay, and again, the one difference on this one is that because we multiplied by 3 in the beginning, you got to go back and divide by 3. Where this one doesn't simplify, so it makes that 3x minus 1. This one does simplify, make it x minus 3. Okay, so we started off with these two denominators. Here's where we got to go back and rewrite them in factored form. This one's 1 over 3x minus 1 and x plus 1. Plus, this is 2 over 3x minus 1 and x minus 3. Okay, so we did all that factoring, all that work to take those two denominators to change them. And once you've gotten it here, then you figure out what your least common denominator is. So basically, this is where you say, all right, what all do I have? How many different expressions do I have in the denominator? I've got a 3x minus 1 here and here, so that's good. I've got an x plus 1, and I've got an x minus 3. So everything that shows up different has to be part of your least common denominator. It'd be like having a 2 and a 3 and a 5 and a 7. Well, if they're all different numbers, you got to go back and multiply them together if they don't have anything in common. Okay, so this one does take a little while. So rewriting both of these with a common denominator. Put this here. Okay, so we had the x minus 1, we had the x plus 1. The extra thing we put in here was the x minus 3. So we do the same thing here. We're going to take the 1 that we had and multiply it by x minus 3. Over here we had the 2. We've got everything. We put in the extra x plus 1 on the bottom. So if we put that x plus 1 on the bottom, we've got to multiply that x plus 1 by on the top. Okay, and this is one where, again, if you write down the LCD, it's going to save you a lot of time because you don't have to write out that expression every single time. Pull the two numerators together. We've got 1 times x minus 3, so there's really nothing you can do there. Plus 2 times dx plus 1. Do a little bit of distributive property on that back end. 2x plus 2. Again, still haven't done it. Still working on the numerator, so don't worry about anything the denominator is going to put. That's the LCD. But this one, again, you do have a 1 there, so it's 1x plus 2x. That's a 3x. You've got a negative 3 plus 2. That's minus 1. Okay. Done with the top. You've done everything you can do on the top. Now you bring the denominator back in. 3x minus 1, x plus 1, and x minus 3. Bringing the 3x minus 1 back in. Now you look to see if you can cancel, and you do have the same thing here and here. So you can cancel that out. And just remember that when you cancel those out, you do put 1s there. So it's 1 over x plus 1 and x minus 3. Okay, a lot of work to those. When you go up to the quadratic denominators, it's a lot more work than with all the linear denominators, just because the x squared terms, just you have to do the factoring, and it's just factoring and more factoring. And most of the problems that I saw, they didn't give you an easy part to factor. Almost every single one of these, when you had to do the factoring here, they were all fairly big in the denominator part of it. So we're 4 over 3x squared minus 10x plus 8, and then plus 2 over 3x squared minus 7x plus 4. And the way these are setting up, there should be, how back here we had when we factored these two things out, that you had the same thing here and here. You should always have something in common when you go through these. So if you do your factoring and you don't have something in common on these parts of what we're doing here, that's kind of a red flag that, okay, something's going to be off. Because if not, the answers are going to kind of get a little bit crazy when we go through these. Okay, so again, we got to factor. And if you want to, we'll just ignore the numerator, because there's nothing you can do to factor those. 4 and 2, there's nothing that you can do there. Factor in this denominator. There's not a good way to get, now, the one thing we do know is it's going to be 3x and x again, but with the 8, there's no telling what the numbers could be, so let's don't do guessing and checking here. Let's go ahead and multiply 3 times 8 to make that a positive 24. So that's where we need the factors of the positive 24 where the sum is going to equal negative 10. Okay. And again, there's not that many numbers. We've got 4 sets of numbers here. Have to key on the signs. The B term is negative, so that negative has to go with the bigger number. And when we divide a positive by negative, that makes the other number a negative. So they both have to be negative. And to add up to negative 10, it's got to be the 4 and the 6. Okay, and here's where, again, you've got to kind of check and look at it. The last number here needs to be 8. This is 4 times 6 would make it 24. So since we multiplied by 3 in the beginning back here, we've got to go back through and divide both of these by 3. Okay, that won't simplify. So we'll do the bottoms up, pull the bottom number up in front of the x. That one does simplify. So that's an x minus 2. Okay, so that was this thing in factored form to get us to here. Got to do the same thing on the right-hand side with that one. We've got to go through and do all the parts here. So we're going to start off with 3 times 4, which is 12. And that's the factors that we're looking for. Again, the B term is negative, so that sign has to go with the bigger number. If we do a positive divide by negative, that makes the other number also a negative. Okay, so it's got to be the 3 and the 4. Okay, but in that same situation back here, because we multiplied by 3 in the beginning to get this 12 for the factors, now we've got to go back and divide by 3. That'll go to 1. This one doesn't simplify, so that makes it 3x minus 4. Okay, so there's our 2 denominators that we have. And again, for the least common denominator, you just got to tell me everything that shows up. So that's going to be 3x minus 4, x minus 2, and x minus 1. Okay, and we left that one so far back there that we don't have it. So we're just going to have to kind of wing it from here. Okay, this one started out over 4, or 4 is the numerator. This one started out as 2. Okay, now, and again, once we've got that one, we really don't have to scroll back up, because to go from here to here, we multiplied in the extra x minus 1. So we got to do the same thing on the top. We put in an extra x minus 1. For this one, we have what, x minus 2? We've got to do the same thing here. We've got to put in an extra x minus 2. And it just changed colors on us. Okay. Done all the work. We've changed the numerators. I'm not going to be able to scroll down because I'm at the end of the page, so I'm going to go to a new page here. So what we're going to do is, again, we're just going to take the numerators that we have and not write out the denominators, because, again, we'll just put LCD just to make it go faster, because, again, it's all about not bogging down too much in here. So we've got 4 times x minus 1 and 2 times x minus 2. And that's all over one big fraction. That's all over the least common denominator. And again, once you get the least common denominator, don't do anything with it until you've done all the adding, subtracting, multiplying, anything you can do in the top. go back and do that. So you've got two distributive properties, one with the 4 and one with the 2. Still got our least common denominator, so we still haven't done anything. Still working on the numerator, so it's just hanging out there. We haven't done anything yet. 4x plus 2x would be 6x. Negative 4 is negative 8. And again, still got one more thing you can do in the numerator. You've got 6x minus 8. You can divide them both by 2 to make that 3x minus 4. Okay, now we've done everything we can do in the numerator. So now we're going to go back and bring in our denominators that we had. And then we do have something that we can cancel, because again, we can get rid of the 3x minus 4s. So final answer there would be 2 on the top, and then x minus 1 and x minus 2 on the bottom.